Well, hi, good morning. Thanks so much for coming and joining me here in my shop. It's February 5th. Now, the last video I posted on YouTube was a video about this scope, this Tektronix 465B scope, where I was just exploring the problem with it to see if maybe I could overcome it. The problem being that it would not trigger. Now, in that video, I discovered that the delay trigger still worked fine. Seemed to work fine. And this presented a pretty good opportunity for doing some troubleshooting because the circuits are very similar. If you just look at them, you can see the similarity through here and through here. This is the trigger circuit that's not working, and this is the trigger circuit that is working. So, but this is the kind of machine I don't have a lot of experience on. I mean, this is a really nice oscilloscope, 100 megahertz oscilloscope, and I've usually got my head around vacuum tubes, which is far and away from here. Of course, there's FET transistors here, there's obviously chips in it, and there's also tunnel diodes over here, various parts I certainly don't find in an old tube radio. So this scope was gifted to me by a very nice gentleman out on the west coast of the United States, a guy named Jim, wouldn't you know it, same name as me. And what he did was we got a Zoom meeting going together, and he guided me through a troubleshooting process. A fairly simple process to start off with, and that was swapping parts up and down. Now, I shot video on all this, but I'm not going to post it because it's a long, drawn-out, fairly slow process of doing this. So I'm skipping all that to the final hour of troubleshooting, where something quite interesting does occur. So that's what you're going to watch. You're going to watch the last hour of about 3-4 hours of troubleshooting. So I'm just going to tell you now what it is we did. Basically, we swapped these two chips. It made no difference. We swapped the tunnel diodes, made no difference, and we did a few other things here. I did an awful lot of testing. I do luckily have another oscilloscope up here, as you can see, which I was able to use to help do some of the testing, looking at wave shapes and taking voltage readings here and there. Jim at his end has exactly the same oscilloscope. This is a very, very common oscilloscope. This one was built probably 1978, 1979, somewhere in there. And what he was doing at his end is in his shop doing the same tests and measurements that I was doing here, and then we were comparing the results and that. So like I said, I'm not going to post that. Excuse me. So you're going to hear Jim's voice. We are doing this over Zoom. His voice is being picked up by the same microphones that are picking up my voice right now. That's the best we could do. We switch back and forth between looking at the Zoom screen and looking at my usual video screen, and there's no cat in that video. And it's a little clumsy at times, and the sound isn't the greatest, but I think the actual troubleshooting is interesting in the end. So that's why I'm doing this introduction, so you understand what you're going to see. And I think the first thing I'll show you is a short clip of Jim in his shop with his pet, in fact. not a cat. So and then from there we'll just flip to this last hour of troubleshooting. I hope you enjoy it. Okay, Jim, show that nice pet of yours again. There we go.
Yep, that's the boss. Or the other boss. This rules the house. Yeah.
What's his name? What's his name? What?
J-I-N-X.
Jinx.
Yeah, wow. Loud too.
Yeah, that is loud. That is really loud.
Well, yeah.
It looks like you got a nice sunny day there.
It's pretty outside. It's cold, but it's pretty. It's probably mid-40s.
Oh, okay, yeah, it's a little warmer here. It's about -5. The last few weeks it's been...
-5 centigrade?
Yeah. Yeah.
Well, we're 4 or 5 centimeter right then.
Something like that, yeah.
Okay, so we were just chatting a bit off video there, and you're reasoning out that it's worthwhile to test this transistor.
Right. It runs off a chip that we hadn't tested, the long black one. And it's also sweep disabled, which basically doesn't let the tunnel diodes reset.
Well, that sounds like the problem.
It could be. The tunnel diodes, when they're turned on and armed, ready to go, are extremely low impedance to ground. That's where they're wiring in the circuit. And that ground effectively kills the signals we were trying to probe while ago with the other transistors. And there's no easy way for me to get a look at them while I'm working without taking the tunnel diodes out. But if I take the tunnel diodes out, that turns about 50 volts loose into this circuit right here that we're looking at and going to look at now.
So
and I didn't want to risk that yet.
That's another sort of principle in troubleshooting, that you can be looking at the schematic and thinking about how the device is supposed to work. But because of a fault in the device, it's working very differently. And so,
that's what we're trying to do.
So it can become very, very difficult to reason out everything. Okay, here we go.
And I cross your fingers it comes up bad.
No,
It reads good, doesn't it?
it's a good it's a 182 gain on it. Pretty strong guy. Yeah, no, it looks fine.
Alright, well, it's not going to hurt anything with it out of circuit for a minute. Not one bit. Let's see, it turns on. Didn't say which one it kicks it. Minus 8 mil, it's kicking that way. Fifteen to 475, so probably close to 0. Turn it on with that transistor out.
You sure?
Yep.
Okay. Okay, it's on.
Give it a second to warm up. Anything looking funny on the
No,
trigger light
no.
or on your scope that's set up to look right now? I can see it as a little bitty thumbnail in the middle. Alright, adjust your level control gently. Let's see if anything does occur.
Nothing.
Nothing.
Oh, she's dead.
And it's not even blinking when you flip the switch now, is it?
No, it won't trigger off the ready light.
Yep. It's not doing anything. Alright, turn her back off. Plug the transistor back in. Remember how it's turned?
Well, because of the arrangement of, yeah, I do, but because of the arrangement of the wires, the leads, you can really only get it back in one way. Famous last words.
I wasn't going to say that. I've been there too many times.
Okay, it's back in. We better.
Alright, turn it back on and let's see if your flipping does stuff again.
Oh my God, I looked at the wrong scope and thought, hey, it's working. You ever done that where you pull up to an intersection and while you're waiting for the light to turn green, you look at the other light and you see it's green and start going? I've done that.
Alright, punch this back up in normal mode.
Oh yeah, okay, normal.
Alright, now try your level gently in your switch.
What if I piled a stronger trigger voltage into the external trigger?
It might actually help, but the only way you're going to do that's with a direct
Okay,
connection.
so we got the single fire thing happening again.
Single firing deals there. Well, why not? Take your probe loose and hook up a straight wire into that connector some way.
Well, I'm going to put a output from a signal generator. What kind of voltage is that thing looking for?
Well, I tell you what you can do. Turn the scope off. You got an alligator clip lead that's good.
One right here.
All right, take that loose on the VNC. Disconnect the probe.
Well, this is what I've got on there now.
Right. All right. Take your probe loose from the calibrator and the external end.
Yeah. But it
One
wasn't.
alligator clip lead to the connector. On the back side, unplug the probe completely.
It is. This is not the probe. This is a clip lead. This wire here.
Oh, okay.
Yeah,
All right,
so-
all right, I got you. All right, hot lead on the clip lead to calibrator.
We're just bypassing the probe.
Right, we're just taking the probe out of circuit.
Okay, so the probe was set to ×1, luckily, too. Okay, try again.
It was ×1. Well, try it then. It probably don't act any different.
No, it shouldn't, anyway. Okay, so there we go. So that's the that, and this is this. That's that, and this is this.
Same symptoms. Yep.
Okay, so well, let me try putting a stronger signal in here. But I don't know what level.
Oh, about 1 volt, 2 volts.
Okay, I can get that.
You're not working with tube gear.
I can get that. Yeah, I said before, that's the whole problem. It's not the tubes. Should have built it with tubes. Okay, so
I'll take the 5th. I've worked with both. I love tubes for being rugged.
so I think this is around. Just checking the frequency here. 50 what? 50 kilohertz.
You can go 50, you can go 5 kilohertz. I don't remember what the frequency is.
Okay, that's 5. That's 5 kilohertz. Okay, and I'm just going to jack up the level here. First, I've got to. Now we've got this set right. We're on external.
External's all you need.
Normal.
Do divide by 10 to start with.
Well, I've got a vernier here, and I've got pads and everything, so I can control it from over here.
Okay, all right. We'll just
Okay,
go-
so we're going up, up, up. I don't know exactly what voltage, but something. Okay, now I'm going to take the pads out. 2 of them anyway. That's a 30.
Don't go too high. Don't go too high.
Don't go too
All right,
high.
Try your level control.
Okay, hold on. I'm going. Now we're all. This is giving it everything.
Well, turn it back down.
Okay, now I got to try this.
Right.
So the output could still be quite low from this. It's not very strong.
Well, probe with your other scope and see how strong it is. We don't need more than about 3 to 5 volts at the most.
Okay.
You can flip it up right behind the BNC connector.
I can get it over here. No, I got it. You're right. I can do that.
You can see down there on the BNC
Yep.
where you
Yep. Okay, so up here we're looking at 0.5 volts per division, so we're half a volt here. Half a volt peak to peak. We can go up. That'd be that's about 1.5 volts. Let's go a little higher. Is it because it doesn't work? Okay, here we go. Nada. How high can you go? You go to 5?
You could go to 5, but you're not getting anything at 3. No, it's not going to do it.
Well, I'm thinking something's out of range.
Go back to pin 2 on the black IC. Probe pin 2 on the black IC, and then rotate your trigger knob right
Look at.
there. What do you get?
All I did was jack up the input here. It's
you
working.
got 5 volts coming in at this trigger now.
Haha.
Well, I guess you fixed something.
So what do we got? We got 1, 2, 3. We got 5 divisions at 1 volt. That's 5 volts. Now let's just check the trigger level. See, the trigger level's way off to the side.
Well, that's fine, but it is acting normally.
Why don't we try that center adjustment and work this back?
All right, center your knob right there.
Hang on.
You don't need me. You got to fix yourself.
Yeah.
We just got it working.
Well, this is a pretty good place to be. Now I'm gonna.
Yeah, I'm thinking too hard.
It's the center one that I should try? Slope center.
All right, hold on a minute. Hold on a
Okay.
minute. Make sure you're on a slope center.
Well, sure. Sure. So we're gonna turn this till it quits.
Hold it. Hold on just a minute. Hold on.
Hold on.
You got your trigger level front panel. You got your clarity. You got a coarse trigger level internal. Let's try that one first. I think it's the left pot. Your trigger level instead of slope. Let's try that one first.
Okay.
And then we'll walk it down like you do a radio in a sense. We'll turn the level down.
Trigger level. Okay, trigger level.
A trigger level.
There we go.
Right.
So I'm gonna turn this till it stops triggering, and then try to make it trigger again with trigger level.
Right, you're trying to walk it back towards center.
Okay, so it's basically out of range. So I got a small improvement by turning the adjustment back here, maximum all the way to the right. And that enabled me to reduce this a little bit.
Alright, hang on a second. I wonder if we've accidentally fed something in it or whatever using it on the tube gear that may have fried it in front of the pot.
No, I don't think it's too likely. I've done something like that.
Well, there's a lot of difference in hooking something up to 300 volts and picking it up to 30.
Yeah, I'm very I'm very conscious about that. So I wouldn't normally scope like a plate.
Yeah.
I'd be very anxious to do something like that.
Alright,
In fact, normally I'd stick a capacitor in there, even though you shouldn't really need to.
yeah.
So
Where's your knob on the front set now? Almost all the way to the right?
almost all the way to the right. Why don't we try? What about the center now? Because there's still
Walk
two
it
more.
back. Okay, let's try the slope adjustment. But now walk your level control on the front.
No, it looks like it just quit.
Alright, go back to where you were.
Luckily I marked this one, so I'll put it right back on the mark.
Alright. So the
So
slope's not having anything, it makes it just quit.
Oh no, it does make a difference. Like that's the slope adjustment.
But it doesn't get you back toward closer to
No,
center.
no.
Alright, that's fine. Keep it working with that right now. Let's get your little voltmeter and do a voltage measurement. I want to know that pot's too far. If the pot's screwed up or damaged. It's got a 0.01, a 680, and a 56. Those are all low values. They're off the 10K pots.
Now wait a minute. Let me just flip this to line for a second. Not happy with the line.
You probably don't have enough level off the line.
That's probably what it is. It's just not enough to get there.
a second. Let me look at something. Let's go back to pin 2 or 3.
Okay.
With your
Just
scope,
gotta-
with your scope probe. Probe pin 2 or 3 on the black chip.
With the scope probe.
With your scope probe. Probe pin 2 or 3. And let's see if we got a real distorted waveform on that FET that's feeding everything.
Okay. And where is that? Oh, here it is.
Because I never even measured my input levels on the FET. Mine was working. I didn't even look.
2 or 3.
2 or 3 on the black chip. And just see how much amplitude we got on your old scope up there. See, we're just
Okay,
blowing
here
off
comes 2.
Alright, it's basically one division.
1 division, 1 volt. Peak to peak. And 3,
Okay,
same thing.
same thing. Alright, so it's 1 volt peak to peak there. And that's with everything working right now, right? Alright, turn your generator output level down till it quits. And then bring it right back just enough to get it to work.
Ooh. Not too far.
Alright, now probe 2 and 3 again.
That hardly changed. That hardly changed.
Alright, probe 2 and 3, and let's see. Increase sensitivity on your little scope.
3. Pardon me?
Turn the sensitivity up on your bench scope. The old one. Get it 3 or 4 divisions so we can see. We're looking for a little bit of change. I want to find out what the threshold is.
Okay, this is 2.
Why is it taking so blessed much?
Ah. Well, that's kind of weird. Oh, I've got it on DC here.
Yes. There you go. Center and loop and 0.
Okay, here we go. 2.
Oh, that's so little.
Whoop, 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 whoop.
Alright, you got how many divisions?
Yeah, 1, 2, 3, 4, 5, almost 6.
Almost 6. Now flip the line.
What's that?
Flip the 465 to line.
Okay, it's online.
Now probe the same,
It's just not enough.
almost 2/3 of it is not enough.
So, now there's an amplifier ahead of this, isn't there? Those 2 black transistors in the heatsink?
Well, we're looking after that. That's what I'm saying. I'm trying to see if your amp's lower than mine. So let me probe mine and see what I got. But you got something working.
Well, yeah, well, what it says to me is, there's nothing really serious has happened here. It's going to be a single component problem.
Well, your instincts are better than mine at this point. Means I gotta get some sleep. Okay, let's see, 2 or 3. All right. All right, mine triggers.
So another possibility is to move the external input up onto the B and then check on the other chip. That's just another approach we could try taking.
Mine's putting out, oh heck, less than half a volt, and I'm triggering fine.
So that's on the line.
That's online.
So line's producing.
Mine's got plenty of range to it online.
Yeah.
So my FETs are putting out basically half a volt.
Well,
This is online.
some kind of offset voltage is incorrect.
Well, I'm trying to see if the transistor's hurting, just not giving enough gain, or if it's something with the offset there.
You know, I could pull those out, although it's scary, and put them on the tester. But I wouldn't have anything to compare them with. Well, I have to pull the ones out up above too.
Yeah.
And it's 6 leads coming out.
It's 6 leads, and as long as you pull them right, they pretty well line up perfectly.
Yeah. When
Hang on,
yeah,
get their twisted the same.
they line up perfectly until they don't, and it's not visible. So that's a risk pulling those out, and getting the heatsink off them, and then put them in, put the heatsink back on.
You pull them as a pair.
Yeah, I know, but I'm thinking ahead. If you get into trouble, how do you get out?
Yeah.
It looks a little scary.
Okay, so we know levels in this. So that clears all the trigger circuit and the switch circuit and all that crap.
Hey, so is that heatsink bound to have a little bit of heat in it?
Not really. It's more for thermal tracking, like room temperature.
Right. Keep them both going together.
Transistors themselves don't get hot enough to do dilly here.
Well, that's provided everything's working right.
Yeah. I mean, if you touch one of them and they're warm.
You know what I did? I touched that heatsink with my finger and it triggered the scope. I probably have static charge.
Yeah.
Shame on me.
But I don't feel any heat on them.
Well, these are warm.
They're a little bit warm. That's it.
Feel the same as the other two.
Yeah, they're a little bit of warmth to them.
Not much.
Yeah.
Because
I'm trying to find out how to get a good reference level to measure the voltage output with the same input that you got.
Because I do have a thermal viewer, which would show up variations.
Yeah, I remember that. But I'm not so concerned with that. I want to know why we got low level.
Another thing I could do is I could just move those transistors in and out a little bit without actually pulling them out of the socket, in case it's a contact issue.
Yeah, you can try that. Turn the scope off before you move them.
Give it a moment here.
So wiggle them and see.
Yeah, if I pull these out too far. Of course, the level thing to me says bad resistor.
Well,
maybe is there a diode in there that's controlling a voltage in some way?
No, but there's a capacitor that controls the gain of the section.
What's that, 3 feet?
22 buck capacitor. Little 22 picofarad capacitor that controls the gain of that section. And 2 resistors, basically. We swapped the chips, it didn't make any difference.
Right.
Alright, turn her back on.
It's on.
Did it make any difference?
Didn't make any difference.
Control still flat out.
I'm still using 5 volts input here, and limit. This has to go all the way to the limit.
So you're having to pump it with a 5-volt signal to get it triggered.
Okay, so I'm going to put it right on the edge of triggering. While you're thinking, I'm going to get a stick and beat this thing up a little bit.
That'll work.
That's about the best I could do. No, I don't want it triggering. I want it just to stop triggering. That's perfect. There. Ah, no it isn't. Okay, let's just go a little, make sure it's off. There. Do you want to trigger? Just tickling a few parts here and there. The chance of this working is pretty small. But I had had a lot of luck with these sticks.
Hey, you had luck with your other intuition this morning. Don't knock it.
No, I don't think this is going to do anything. Now, it has to be after the trigger source selector switch. Oh my gosh, I had it on the wrong... Oh! I had it on line. I'm going to go back to using this. So it will trigger on the line. Just way over.
It's way over.
Okay. Oh, 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 oh. What's going on there? Keep poking. Put a little pressure on the board. You really get fooled doing this.
Yeah, you can. So you're on external right now?
Yeah.
Status A coupling. Okay. So external comes through basically 1 minute probe. And external divided by 10 comes through more point.
No, not getting anywhere here. The magic stick's not working.
Alright, don't get too funky with it.
No. No indication of anything doing that. There we are. So this is demonstrating the what happened to it?
Yeah, it should turn right around and trigger.
Well, the trigger level
Yeah, you're
is
feeding a continuous deal.
it's sort of intermittent, so it's perfect for testing this.
Yeah.
It's pretty quick though, isn't it?
So you're arming it, you're seeing the first one go by and
Yeah.
triggering this.
Yeah.
stops.
Yeah.
Alright, the thing is, I don't have a scope on your end that we can trust to make a measurement with.
I stick it on auto. Now it's showing without the trigger. How's
Well,
that?
that's what auto does.
But it never did it before. Oh, or did it? Maybe it did. Yeah, it did.
The
Yeah.
First day we played with it,
Yeah, it
it
did.
was
Yeah.
on auto, but it wouldn't run it, otherwise.
Yeah.
Alright, go back to normal.
Yeah.
Play with control, see if it's still almost maxed out.
You know, I've been told that many times in my life. Go back to normal.
Hasn't worked yet, has it? I thought I had the record on that.
Come on.
Alright. Let's go back and measure something again. We know now that level's an issue. Your pot A trigger level's cranked all the way over.
Yep.
To get it in the right range to do it. That could be a DC offset in the FETs.
Yeah, what happens if we do that?
That's what DC would do to it.
So, how about this? The negative and positive doesn't seem to make a difference. Let's just put it on the edge here.
Well, it's actually starting to look like the other FET. Alright. 3.4. Get this for a match pair. It doesn't show a static symbol. And new JFET completion modes. Alright, let's pull a pair of FETs out. There's an issue that can make it act the way it's acting a little bit. Let me run this by you and see what you think.
Okay.
Alright, the FETs up front, the two of them.
These
One is called a current load, that's the bottom one, 7324B.
You're talking about these in the heatsink?
Yeah, those two.
Yeah.
Right, those two.
You're
The
saying
other two and the ones below it, right below your finger, the two, that's for a different circuit. It's not pertinent to this.
okay.
Notice up on the B you don't have a second.
That's right. Yeah, they're not there.
Yes, no, they're for a whole deal, something else. So the two black ones are all we're talking about. One of them is the top side and the output feeding the big black chip. So that one of them feeds straight over to the black chip.
Yeah.
The other one is what's called a current load. It's a little current generator that just puts so much current load on the top FET.
It's a constant current source?
Constant current source, yeah. The deal is, if it goes bad, it can drag it down to where the other one's got to really hump it to get it back up in range to trigger on. In other words, his brother can hurt it just as much as it can.
Think these are swappable?
It's either swap them or pull the one out that we suspect, the two bottom ones, and test them with the thing in the fixture like they are.
That would be first approach.
You'll have 3 leads hanging in the thin air and 3 leads up to your little tester. JFETs are not normally super static sensitive, so I just turn the scope off.
I'm grounded.
And I pull them out. And don't take them out of the fixture. Mark which end of the fixture is what.
Well, again, they can only go in one way.
Alright, but the threads are pointing straight toward the ceiling.
That's right.
Alright, so now use your tester and test one at a time. Now these FETs, if you put them on a meter, to look at them with a meter, they're what's called depletion mode FETs, which means they're turned on all the time. You apply a gate voltage to them to turn them off. So if you read them with a voltmeter, they'd read 3 or 4 ohms, something like that to start with.
They look like they're shorted.
They look like they were short. But now your tester should be able to sort that out.
I think so. Okay, ready for number 1 here. And
That is short.
JFET.
This should give you a gate source voltage.
1.8 volts,
1.8, 100 mils.
2.6.
Alright. Drain source gate. All right, check the other one.
So it's saying if you put 1.8 volts on the gate under this
Yeah,
test, you get a
I
two.
literally start turning it off.
You get a 2.6. Okay.
All right, try your other one. And I try to maintain the same leads if you can.
It won't matter. The machine figures it out.
It will though. If they got bias diodes for steering to route things to different pins and different connectors, JFETs are different if you use gate to source or drain to source.
Well, I'm saying is this tester, you just hook up the leads. It figures out what's what.
Yeah, I know it does, but what I'm saying is you can get a differential that'll bite you.
Well, let's see what happens.
It won't blow nothing, but it'll.
So 1.4 gate voltage, 2 milliamps. So it's different.
A little different, but it's pretty well about the same.
It's not broken, shorted, or open. I would
Okay,
say.
well nothing connected there.
Are these identical transistors? These two?
They're matched pair.
Matched
Which means
pair.
they put them on a testing unit and match the traces up based on different biases to make sure they acted like brothers, like twins.
Okay, but they're not identical.
As close as they can make them.
So if on one lead is bent here.
They'll go through a bag of 50 of them and they'll go through and pick one and then they'll go through the other 49 and keep testing them until they find two of them that are close.
Sounded like I got one lead got bent.
Can you get it back without breaking it?
Well, I'm sure I can. I have to do a little guesswork here.
Well, just be careful.
See, all the rest of them have been. This one, it looks like it was never bent. You know, I'm gonna try just. Let me look at this situation here. I guess when I hooked up the tester, I bent one.
Well, don't aggravate. Just
I have to stick that one in first. Yeah, it's way out. All the rest are good. That's probably the end of the weather warning.
Well, at least now we know what's what. I've got a pair of those coming in. They may be in the mailbox. That's the tunnel diodes. And that's the series chips.
A miracle, but I got it.
Alright, once you're back in, turn around and see if we got the same symptoms. We haven't done that, so we should have.
Okay. There we go. Well, it's triggering. The very same.
Alright, get your little voltmeter again. We want to measure the voltage on pin 2 and 3 going into the black chip. So ground to pin 2 and ground to pin 3 and make sure they're the same. It should be just about dead zero. Disconnect your input. So switch to
Which input are you talking about?
the alligator clip and take it loose for a minute, or get it off your generator, or kill your generator output, whatever.
Like you don't want a trigger signal in the scope.
No, I don't want to feed something in it. I just want to do a DC measure.
So taking this off, right?
Yeah, take it off. Yeah.
Okay.
All right, it quit. That's fine. Just do the DC measure.
If it didn't quit, I'd be upset.
Yeah, but Murphy's go around sometimes too.
Okay, I need my, where'd my clip lead go here?
I'm glad you figured out it was level.
Huh?
But I'm glad you figured out it was signal strength. I've been scratching a hole in my head.
Well, that's a real good hint.
Yep. You
Okay.
can't believe what's on paper too much sometimes.
What do you got me looking at now?
Should be right around 0 volts.
On what was it?
2 and 3.
2 and 3 again.
So ground to 2 and ground to 3 with the voltmeter. Voltmeter's on ground and probe 2 and probe 3 and see if they're both about 0.
That's 2. I wouldn't say that's about 0.
1 volt.
And that's 3. Same thing.
So 1 volt across the board. Alright, that's telling us something in a sense as well. The FETs are matched. And with 0 coming in them, basically they both be turned on the same. They should be about equal. And there'd be a voltage divider between plus 8 volts and minus 8 volts, and there'd be 0 in the middle. And that's what Tech shows on the schematic. And that 1 volt voltage offset could be enough to give us our pots swung all the way over. Alright.
So you're saying that's an unexpected voltage there?
If the FETs were matched perfect, it would be 0. With no gate to source voltage.
Well,
Nothing to switch them. With
You know-
no voltage, turn the FETs on or off.
why don't we swap them?
They would cancel out.
Why don't we swap?
Alright, if you're comfortable doing it, let's swap.
Well, I took one out and got it back in.
Alright, be gentle.
Power off. Now I'd be sacrificing the delay feature, but I never use that.
Well, I've got more FETs ordered. I got 2 matched pairs ordered.
Oh, was that so?
They
Okay.
may be down in the mailbox right now.
Lower
Still
one's
online.
out. Lower one's out. Hopefully these are exactly the same arrangement.
Look at the layout on the PC board first. See if they look appear similar.
They look exactly the same.
Alright, do it to it.
In fact, let me look at the other one. They look exactly the same.
Alright.
If I didn't have this magnifier thing I'm wearing, I'd never be able to do this.
Well, you'll have to find the sheet on it and send me where you ordered it from, because the ones I bought, I ain't never got a good one yet.
Oh, these are cheap too. Like these are terrible, but there it goes. To put the other one in?
Yeah, I'd put it in for safety's sake. That way the amp itself won't be floating.
Okay. Actually, it wasn't that bad.
Alright. Try it and see where your control is
There
now.
we go. Centering the trigger.
Plug your generator back in.
This is in the center now.
It's in the center now.
There you go.
Alright. Drop your input level down little by little when you switch.
So you can see when I rotate this, if I go all the way this way, at the very end it quits. If I go all the way the other way, it stays. So, not quite centered.
All right.
But,
the thing is, we want to lower our input.
I'm bringing it down.
And
Okay, knocked it way down. 30
slope
decibels.
centering deal.
30 dB down. It's gone away.
All right. All right.
Let
That's
me
your
take it
answer
down.
then.
Let me take it down 10. It's triggering over here.
So now you want to
Take it down 20. Triggering a little further over. We're about the same area.
All right. Now use your A trigger level pot on the board in there to basically center things up. The course control that we first turned.
Well,
A trigger level.
trigger
So
level,
you want,
not
you
the
want
center.
the outside knob. You want the outside knob centered. The internal pot, a trigger level pot, the course adjustment inside on the board to bring it back.
Okay, so there's these three adjustments here. This one,
All
this
right.
one, and this one. That's the center.
You want the one that says a trigger level.
That's this one.
All right. You want to adjust that till you get it to pop back.
Shouldn't I try centering it?
Where's your
Because it's over here.
on the
I should try using the center to get it over. You're quiet now.
Well, what I'm trying to get you to think for a minute, the knob on the front panel is a fine adjustment. The one inside on the board is a coarse adjustment.
Okay, here we go.
So you want the one outside more or less centered, then adjust the one inside so it pops back in.
Well, it's getting
when you're
better.
lined up with it.
Getting better. I got to reduce the level.
Now reduce your level, which makes it touchier, and do it again.
We're in business here.
Oh, you get to be a pro now. All right, when you're happy with it, walk it down a little more. Do it again.
Yeah, I'm gonna reduce it till it just about quits here. Okay. Well, you could just turn this trigger level up if you wanted, couldn't you?
Yeah, but bear in mind, it's a coarse and a fine adjustment. It's not an actual level adjustment. It's a coarse and a fine.
Okay.
The slope's going to be actual or major adjustments.
Well,
We're just making the knobs track is all we're doing.
okay, so I have it on 0. I have this centered here.
All
This
right,
guy centered.
now you're fine.
And
All right, now.
I got a
let's go
range.
back to-
Let me just reduce the trigger input a little bit more. So I can find the edge. Oh my gosh, it's very sensitive now.
All right, we don't want to get it too sensitive. You get it too sensitive, and it'll false trigger a lot of times.
Yeah. Okay. We'll have to do
Which
some.
will drive you nuts.
Have to do some more real world stuff. So there we are. That's good. It's in the center.
All right, now let's look at your pots on the PC board.
It's working really good. It's really good.
All right, on the PC board, you've got a slope center and a sensitivity adjust.
Yeah.
Let's try the slope center first.
Well, what am I trying to achieve now? Because I have a fairly low input signal, and the
All right.
scope is triggering on the center.
That's fine. What you're adjusting now is absolutely where it starts to trigger. You're gonna adjust the front knob as a test, but you're gonna put it back to 0 all the time.
Hey, why don't I do this with the regular A channel A input? Try to trigger on that rather than use this external.
You could, yeah.
That might be just a little bit better. Let's see what happens anyway. Without changing the voltage. Huh?
What we've done so far is we made the knobs jive. That's what we did just a minute ago, was make the knobs line up.
Look at that. Oh, you can't look at that.
No, okay.
It's working.
All right, now, what we're going to do now is go in and adjust the A slope center. The pot on the board, it says A slope center. Now we're sliding up and down the curve of the diode.
I got you.
So we're going to adjust it till it quits. Then we're going to move the front one till it starts back a little bit.
You know, I turned up the amplifier here. Now the range is very large.
Yeah, okay.
But this isn't actually freezing. Oh, but it is.
How about that?
Let's take a look. Look at that. There, you can see it moving back and forth a little bit.
Well, if you spread it out a little more, it should walk up down the curve. Find the left edge with
Shaky.
your position control.
Shaky.
All right, that's the sensitivity being too touchy.
Okay, let's back it down.
All right, now the one you come out here is A trigger sensitivity. That's the pot inside. It's R7246. A trigger sensitivity.
Oh. Well, but what about that level? You were saying I turned the level up so high.
They play hand in hand with each other.
Okay. I'll follow what you're saying. Sensitivity next. Okay. Not doing anything. Moving it.
Right.
But still kind
It should.
of a blurry image.
Well, we may be out of focus for all we know.
No, I don't think so. Let me just check that.
You know how a camera makes it bloom out? I can't really judge. You got to focus on astigmatism.
Yeah, no, I think it's good. I think that's because the straight line is nice. I think it's a little shaky.
Okay, you got a filter over there, high frequency reject. Look at it. Did it clean it up any?
It did.
Oh, okay.
It did. It did sharpen it
All
up.
right. Also on your left side, on your vertical channels, hit your bandwidth limit.
Didn't do anything,
Clean it
but
up any?
it didn't change it.
All right. Well,
But you know, this is a very small voltage.
Yeah, that's the point. It's going to be that way. All right, inside the pot you're adjusting, the sensitivity, if it acts up with you, that's what you hit first. The slope's going to set us closer to an edge, but we got to balance the two in a sense. You can get it close to an edge and it gets super sensitive, or you can slide it with the sensitivity control and get it close to an edge and it gets too sensitive. We're looking for a happy medium. There's a procedure they got in there to go through and follow it. And we haven't really moved it. You
Okay,
guys still got dots marked.
So this is a slope here.
I put them back on the dots right now.
Back on the what?
The dots that you marked yesterday.
Okay.
So for those two pots, the slope and the sensitivity, line them back up with the dots.
Okay, they're lined up.
All right, now just try it on the front panel, see how it feels. But always go back to 0 on it. You kind of literally want it to quit
It's perfect.
equal amounts from center.
It's perfect. It's quitting equal sides. Let me flip it to negative.
Flip it to negative and try the same thing.
Perfect.
All right, leave them alone then.
We're done.
Now you're a pro.
There it is. So the essence of the problem here is a couple of unmatched FETs. One of them is drifted off.
One of them has gotten hurt or faded over time,
Yeah.
causing an offset, that 1 volt you saw on your digital.
Yeah.
And that offset threw everything off to the point it wouldn't work anymore.
Well, it's great.
So they degraded over time. So one of them is not close enough to the other one for things to function right.
So now if we switch over to B.
B, you may have the same issues before.
Now-
You may not get B working.
Now it's not going to trigger.
So the point is, I need to send you a pair of these FETs, and they're from Tech. You should be able to exchange them for the two you got in there, And I would put one in at a time with the metal heat sink off, but don't run the scope too long, because they will get hot
Yeah.
with no metal. But once you got them in there, kind of lightly screw the metal down to it. Unplug one after you mark the orientation good on the metal, and tighten the screw a little more, and plug them back in gently as a pair. But you don't want to let them run 20 minutes without the metal on them. So you pull that pair out, take the metal bracket loose, put singles in, put the clamp metal around it, line it up the best you can, pull it out and get one tightened down, or mark each one, mark the black and the metal so they line up, and then pull them out, put them together, and try to put them together as a pair.
Now you can't see it on the camera, but with my eyes, I can see the steps in this waveform.
That's coming from your generator now.
Yeah, yeah.
You put an old style generator on there.
You wouldn't see that.
Digitally derived, and you won't have that stuff.
So nice square wave.
See if it triggers good.
So you can go up and down on one side, and up and down there. Perfect.
Now you're getting to be a pro. You make me
It's
feel
perfect.
good.
Perfect.
But I didn't think that you did. I was off on another track.
Well, you know, you do too. I spent a lot of time fixing stuff. So,
I spend more time arguing with myself, though.
well, that's great. Turned out to be a relatively simple thing, and that's great.
All right, I'll send you a fresh pair of FETs.
I'd appreciate that, Jim.
Uh,
Thanks a lot. I learned a lot about this scope. I feel like, much more of a in control.
Well, I just wanted you to be cautious because I knew this wasn't the world you're used to. It's not so much the circuit. Yeah, you're used to that to some extent, but it's the little bitty things like those sockets.
Oh, I've learned the hard way so many times that there's a risk to everything.
Well, that's true.
And if you don't recognize it ahead of time, you're going to have it afterwards.
Well, your
Yeah.
beauty of tubes is they'll take some abuse and get away with it.
Yeah, that's
The
true.
transistor will not.
That's true.
Transistors give you the finger first and the smoke second. So,
Yeah. They don't even give you the smoke.
sometimes.
You
Okay.
get nothing. Fantastic.
All right, now,
Fantastic.
Before you get things messed up, let's shut it down. Put the covers back on.
Well, that's a big job in here.
Yeah, I know it's a big job.
Time for
Before
lunch.
you set it back up on the shelf, check it again on the bench.
Okay.
It's a pain to put up there and restack everything on it.
It is a bit of a tough go, but I think I'm going to avoid screwing it into the cabinet. That way I can extract it out again.
Yeah, well, my stuff I built
So-
little cabinets within cabinets, so just
Like I'll show you.
resign it.
Like, see, the cabinet's right here.
Yeah,
Come on, come on.
I
Work.
just set the equipment up in them. Make
So-
me a cubby hole and set something in it.
Perfect.
So you feel better now?
Yeah, sure, of course. Because, even though it can be a long road, if it ends in a good place, journey's worth it.
Okay.
Very good.
All right, well, button her up. Check her again right before you put her back where she belongs. And enjoy some more.
Okay, Jim. Thanks a lot. See you later.
Enjoyed it.